Hello everyone. So now we are going to discuss the OSPF, Open Shortest Path First. This is also a routing protocol. This is a dynamic routing protocol. As we discussed in our previous class, OSPF is a dynamic routing protocol. It is a open standard, means we can run this in any router. We can run this routing protocol in any vendor. Not only Cisco, we can run in the Juniper or any other. And this one is working on the link state. OSPF is working on the link state. Link means interface. If you have the router R1 and you have any interface F0 by 0, whatever the information for this interface, if this interface go up or down, OSPF is going to share that information to the neighbor. We are going to check that one. Now we need to remember OSPF stands for Open Shortest Path First. It is a standard protocol and it is working on the link state. It is sharing the link information, and what we can say, it is having the protocol number type 89. This is the port number is 89. OSPF protocol number is 89, and it is using the algorithm shortest path first. And in OSPF we can connect the unlimited routers. We don't have limit here, but Cisco recommend to connect 40 to 50 router. But if we want to connect more router, we can connect more router also in the OSPF. And OSPF, as we told, metric we have, as just now we discussed, RIP is having the metric as a hop count. Hop count we have for RIP. But for OSPF, what we have, OSPF is having the COS. OSPF metric is COS. Later we will see, we will calculate. Now just remember, OSPF is having the metric, that is COS, and how we can calculate, we have the formula 10 to power of minus 8, 10 to power of 8 divided by bandwidth interface. This is a reference bandwidth divided by interface bandwidth. When we divide, we will get the COS. So whenever we have the routes in our routing table, OSPF is going to check whoever is having the low COS, that route he is going to store in our routing table. And OSPF is having the external and internal administrative distance as 110. AD value, if you remember, we discussed before, we have the AD value. Depending upon the AD value, he is going to store the routes in our routing table. Now remember, just OSPF is having 110, RIP is having 130, and static route is having the 1, as we discussed before. We are going to verify, we are going to check this one also. And OSPF is supporting to VLSM and CIDR. VLSM is nothing but variable length subnet mask. CIDR is nothing but classless interdomain routing. In simple words, we can say it is supporting the subnetting, and it support only equal cost load balancing. When we have the two router, example, I have one router here, I have another router here, I have one more router here, and I am getting some network here, example 8.8.8.8, and here I will write 8.8.8.8, and here I am getting this same network from the two different route. And if the COS is same both the side, example COS here is 1, here is 1, so OSPF will do load balancing. He will send one packet from here, one packet from here. So what we are saying, OSPF only do equal cost load balancing. If the cost is equal, then only he will do load balancing. Whereas EIGRP is going to do unequal cost also. EIGRP is doing equal as well as unequal cost. We are going to check that one later. But now remember, OSPF is doing only equal cost. And in the OSPF, we have the concept of area for easy management and control of traffic to stop the LSA flooding. We have the LSA, link state advertisement. Link state advertisement, because one router is going to share his information in the form of LSA, so we will have the LSA flooding. So we introduce the concept of area in the OSPF. So we are going to see what is that one. We need to remember, area 0 must, we should have the area 0. Must have one area called area 0. All area must connect to area 0. Example, I will create here, this is a area 0. I have so many router connected here like this way, and example, I have another area here, area 1, and we have so many router here also connected, some here like this way. And if we want to make communication, we need to connect to area 0. Example, if I have another area here, area 2, I have another area as a area 2. If I connect 1 to 2 directly, it will not work. We need to connect to 0 only. So that's why we are calling area 0 is a backbone area, and here we need to connect all the area to area 0. If you don't have area 0, area 1 will not communicate to area 2. But we have another logic also, we can make the communication. But now remember, area 0 is must. Without area 0 we cannot make the communication between two different area. Later we will see how we can make the communication by using virtual link and all that one. And then what we have, it support authentication, so we can put the password also. When we configure the OSPF, we can put the password also. And what we have, OSPF is using the multicast address 224.0.0.5 to send the hello packets, and OSPF using also multicast address 224.0.0.6 for all designated router. We have DR, BDR. Later we are going to see that one also, what is DR, what is BDR. And conversion is fast, and every 10 seconds they are sending the hello packet. So this is an interview question. We need to remember, hello timer is 10 seconds, dead timer is 40 seconds in OSPF. We need to remember, hello timer is 10 seconds, dead timer is 40 seconds in OSPF. And in OSPF they will update the routing table only particular link. If any link go down or up, then only they will update the routing table. And what we can say, in OSPF we have three table. We have the neighbor table, we have the database table, that is also known as topology table, and we have one is routing table. So this three table is available in the OSPF. We need to remember, in neighbor table neighbor information is available, in database table complete topology information is available, in routing table the best route is available in the routing table. And OSPF is supporting the IPv4, IPv6, both are supported by the OSPF. And OSPF send all update in the form of LSA, link state advertisement. And they are using one sequence number, like this is a sequence number. They will start from here, and whenever there is any update they will increment plus one, like here 1, then 2, 3, like this till it reach to this number. After that again they will start from this one, they will reset and they will start from here. So this is the theory about the OSPF. This is very important. You need to remember, OSPF protocol number is 89, AD value is 110, and cos metric is cos, and we can calculate 10 to power of 8 by bandwidth. And it is supporting subnetting. Area 0 is the backbone area, all area must connect to area 0. And we have two multicast address, one for the hello packet, one for the designated router, and we have hello timer, dead timer. We need to remember this. And we have three table. Neighbor table is having directly connected neighbor information, database table is having complete topology information, routing table is having the best route in that one, and it is supporting the IPv4, IPv6, and it is sending all the information in the form of LSA, link state advertisement. This all points we need to remember, because in interview they will ask you. This is very important points. And how we will configure OSPF? We will write router OSPF 1. This is a process ID. You can write 1, 2, 3, anything you can write here, no issue. I will show you when we configure. Then we need to write network and network ID of that interface. Whatever IP is assigned, we need to write network ID of that IP. Then we need to write the wildcard mask of that one, and then we need to write area, and in which area we have this one. Example, if it is in area 0, we need to write area 0. And if you have another interface, example, I have one router, here I have this one interface here, 1.1.1.1, here is 192.168.1.1.1. So network ID will be, this will be 0, and this will be 0, this will be 0, this is /8. So this is the network ID, so we will write here that network ID, and wildcard mask will be 0.255.255.255, and then area 0. Here also we need to calculate network ID, wildcard mask, and area 0 if they are in area 0. We will do first lab for area 0, later we will do the lab for area 1 and other area also. So we will see this one, we will do now. And when we write here, like when we want to check the neighbor table, as we discussed, we have three table. One is neighbor table. Neighbor table means directly connected, whoever is directly connected to router. If I have one router here, another router is directly connected, this router information is going to store here. So how we can check? We will write show IP OSPF neighbor. With this command we will check the neighbor table. We have the neighbor ID, we have the priority. By default we are having the priority 1. We can tune this from 0 to 255. We are going to check this again later. And this is a state. State is full. We have the 7 states. We will discuss later what is state 1, state 2, all that one, and packets also. Now just remember, here it is showing state as full and BDR, backup designated router. We have DR and BDR. What is DR, what is BDR? No need to worry, we are going to discuss that separately. Just I am showing you what we are getting in the neighbor table. And this is a dead timer, as we told, 40 seconds. So we will have 40 and they will decrease this, -1, -1, -1, and he should receive another packet, hello packet, so it will become again 40. If this time becomes 0 and he did not receive, he will remove this entry from the neighbor table. And this is a neighbor address, whatever the IP for the neighbor, and this is the interface, our living interface, our interface which is connected to the neighbor. So we will verify that when we will check now. And then we have the database table. It is also known as topology table. List of all link means it is like a table where it will show us all the information about our routers. Whatever link, whatever information we have, it will come here. So how we can check? We will write show IP OSPF database. Complete database will be available. Here it is showing we have the OSPF router with the router ID is 2.2. This is a router ID. How we have this router ID? Because we created the loopback 0. So he will prefer the loopback 0 and take that loopback 0 IP here. And this is the process ID, we are using 1. And this is the router link state, it is area 0. And this is the link ID, this is the link ID 1.1.1 and 2.2.2. 2 router we have, so 2 router ID they keep here calling as a link ID. And this is a advertised router. This router, whoever is advertising our network, that router ID here. And this is the age, and this is the sequence number, and this is checksum value, and link, how many link he is advertising. He is advertising 2 link. This guy is also advertising 2 link. And this is a network link state. This is also area 0, and we have the link ID about our router information and our router whatever we are advertising. Age we have this one, and the sequence number, checksum value. So we are going to see this all detail in the coming classes. And the routing table, last one is the routing table. Routing table, as we already know, routing table keeping the best route. It contains the best path towards the destination. How we can check? We will write show IP route. So when we write the show IP route, we will get here O is nothing but OSPF. Okay, and if you see this O, you learn this route from the OSPF, and OSPF AD value we told, AD value is 110. So here you have 110 here, and this is a metric came from the cost. Later we are going to check how we can calculate the cost. So now we have the cost is 2. This is if we want to go to this network, we need to forward the traffic to this IP, and from this much time the neighborship come up, and this is our leaving interface. We are going to check that one also. Now we will do one lab, so you will have idea. Okay, so this is the basic about the OSPF. Let me stop this recording.